Hi everyone, welcome to the next video in our series. Now, this is going to be a series of videos and they're mainly centered around this idea of lines and parabolas interacting. And if we were to graph these two, our line or our parabola, and look at the points of intersection, how many solutions are we going to have? So in essence, we're building up to solving simultaneous equations because we have two equations, one for a line, one for a parabola, and we're going to slowly work through this using a bunch of different examples. Now, before we start, hopefully this will be a shorter video. When we graph a line and parabola, a few different things can happen. Now, we know what lines look like, we've graphed those before. For example, if I have a line like this, I have my line, it's got some equation, and if I drew a parabola, for example, up here, this is any parabola, we want to see, are there any solutions here? Are there any points of intersection so that when we solve a pair of simultaneous equations, will we get solutions? Now here we can see pretty clearly that this line and this parabola and this line will never cross. So, because they won't cross, we can say there are no points of intersection. Okay, cool. That's relatively straightforward. We can clearly see this parabola is going to shoot off up here at a pretty fast rate, and it's never actually going to meet this particular line here. So there are no points of intersection. Now, sometimes with the questions we're working through, we will have one point of intersection. So if I draw my XY plane, I have this line, for example, and I have a parabola that touches it at one point. This particular thing here, now I know it looks a little weird in the way I've drawn it, but my parabola meets my line at one particular point. So we have a special name for these type when we have, for example, one solution or one point where they intersect, and this is called, so we have, for example, one point of intersection, and we have a special name for this when we have one point of intersection. We call this line that touches the curve in exactly one place, we call that a tangent. So we say the line is tangent to the parabola. Now let's look at one more case and then we'll just jump into a couple of questions. But I have a y, we have my x, I have a parabola and a line here. Now I can see here that we have two particular points where these two graphs cross, and one of those will have some solution xy, and the second will have some solution xy where they both meet. Now here we have obviously 2 points of intersection, and we have a special name for this line that goes through the parabola and meets it at 2 points. We call this a secant. We call this line here a secant. So these are just some initial definitions, and we're going to get into a lot more of these. We're going to split this up into a lot of different parts. Now, just for the first couple of questions here, And the only questions from this video, we are going to be looking at points of intersection with a parabola and a horizontal line. So, question 1, we want to find the intersection points between the graph y equals x squared minus 3x, this is our parabola, and the line y equals to 4. Okay, now we're looking at solving these simultaneously. So we've done this before, but for 2 lines. Now let's look at how this would work with a parabola and a line. Now I have that one y value is equal to x squared minus 3x, and another y value is 4. But now remember, with simultaneous equations, we're looking for points of intersection. So at that particular point of intersection, the x's and y's are equal. Sorry, that's really bad handwriting here. Let's try that again. My x's and y's are equal. So I have that my y on the left hand side equals something on the right hand side, and another y equals 4. At that point of intersection, these two are the same. They are identical. So if the left hand side is the same and identical, then the right hand side is also identical. So we can set x squared minus 3x to equal 4. This is what we did with substitution in solving simultaneous equations before. Or in other words, we're just putting this value of 4 here, y equals 4, so I can put 4 in place of y here. There's 2 different ways we can think about this. But that means that I can say that x squared minus 3x equals to 4. And now we have a quadratic equation that we want to solve. And now first, remember, we need to get this in standard form. So I want everything on the left-hand side equaling to 0. So I'm going to subtract 4 from each side. This will give me 0 on the right-hand side. And on the left-hand side, I have x squared minus 3x minus 4. And that equals to 0. Now, there are a ton of ways we can solve this particular equation, but let's just try something that we did a while back and see if it works for this particular question. We want 2 factors that are going to multiply to give me negative 4 and add to give me negative 3. Now you can pause this and have a go at thinking of those 2 numbers, but we can see that minus 4 and positive 1, if I times those together, I'm going to get a negative 4. If I add those together, minus 4 plus 1 gives me minus 3. So I'm just going to factorize this in the quick way. Now you can do this the longer way. If you've watched some of the previous videos from the Year 9 content, you can do this in any way you'd like. But once I have the factors, I can just substitute them into here. So I have positive 1 and I have negative 4. So I can say that this factorizes to x minus 4, and the other bracket is going to be x plus 1. Now, that is this particular thing, just written in a different way. So I have my expression on the left-hand side is going to be x minus 4, x plus 1. That equals to 0. And remember here, when we have these brackets next to each other, there is a multiplication happening. And using what we have talked about before on this channel, we're going to use what we call the null factor law. In order to get a product of 0, one of the expressions multiplying here have to be 0. That's the only way we can get 0 as a solution here. So I'm just going to go straight into this because we've done this before. If you need more of an explanation, please look at some of those previous videos, but these are going to be the solutions to my quadratic equation here. So I have the two x values which are I have 2 points of intersection essentially. Now with simultaneous equations, when we looked at lines, at these linear things, we had a line going like this and some line going like this. So they only ever intersected at one point. But because of how parabolas and lines look, parabolas are kind of like multi-directional. They loop around a little bit. So some parabola like this may meet another line, not all the time, but sometimes, at 2 points. So here we have two solutions here. Now I've found the x values of those 2 points. How can I find the y? Well, I have to just substitute my x values into either equation 1 or equation 2. Now, I'm going to substitute this into equation 1 just to see what I get. And then afterwards, we're going to pick up on if there was something easier we could have done. And now, sorry, keep in mind, this is a horizontal line, so it's going to look kind of like this. Okay, so we're going to sub x equals 4 into equation 1. So I get that y equals 2, 4 squared minus 3 times 4, which gives me 4. And I can sub this, I can sub negative 2 as well, sorry, negative 1. So sub x equals negative 1 into 1. So I get y equals 2 negative 1 squared minus 3 times negative 1. So I get 1, and then minus 3 times minus 1 gives me plus 3, positive 3, and that equals to 4. But now some of you may be looking at this and going, well, wait a minute, why did you sub it into here? Couldn't we just, haven't you always said that we want to go through the path of least resistance? So we would look at this second equation here. You are absolutely right here. The y value, because this is a horizontal line, it's always going to be 4 all the way through. I just wanted to show you that if indeed we wanted to substitute this into 1, we would get the same value for y. Y is always going to be 4 because we have some line, some horizontal, perfectly horizontal line crossing a parabola. So looking at the direction here, the y value here is going to be the same as the y value here. And those are always going to be the same value. And that's just the nature of the horizontal line here. Okay, let's do one more example. And we're going to do this obviously the easier way. We don't have to do all of this business here because we can just read off one of the equations and we know that no matter what I sub into, I'm going to get the same thing. But just taking the equation of the line, y equals something, that's a much easier place to go in order to find the y coordinate here. But those y coordinates will be the same because it is a horizontal line. Okay, question 2. We have two equations, y equals x squared plus 2x plus 4 and y equals negative 2. Now, once again, for these ones, we are going to solve by substitution. We're going to recognize that at the particular point of intersection, these y's are equal. So the two right-hand sides, this expression and this expression, those are equal as well. So I'm going to have x squared plus 2x plus 4 on my left hand side equaling to negative 2 on the right hand side. And now this becomes a quadratic that I can solve. First of all, I want it in standard form, so I'm going to add the 2 to both sides in order to get this in standard form. Everything together on the left side, that equals x squared. That gives me, x squared plus 2x plus 6. And I have 0 on this side. Okay, so I can try to use PSF here, but I can pretty clearly see there are no two numbers that multiply to give me 6 and add to give me 2. So this is going to be really hard to factorize. So let's look in our bag of tricks and we'll try something else. Let's try maybe the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, my a here is going to be 1. When we just have x squared or any pronumeral, the coefficient, the number in front of it, we can assume is going to be 1. So substituting this in, I have my a, I have my b, I have my c. Popping these in, I'm going to get minus 2 plus or minus the square root of 2 squared minus 4 times 1 times 6. And that's going to be over 2, because 2 times 1 gives me 2. Okay, now let's start simplifying this. We have minus 2 plus or minus. Here, I have 4 minus 4 times 1 times 6 gives me 24 over 2. But look at this guy in here. In other words, my discriminant, right? We talked about this before. If I were to simplify this, I would get in my square root negative 20. So can I actually get a solution here? Well, no, I can't, because this will give me no real solutions. Anytime I have a discriminant that is negative, or just any number under a square root sign that is negative, I'm not going to have a real number. So I can say no real solutions. So that is my answer. I can't solve this using PSF, I tried that. And when I try to solve it with the quadratic formula, which is like this blanket solution that we learnt usually fixes everything, sometimes this discriminant, my b squared minus 4ac, is going to be negative. If it's negative, I'm going to get no real solutions. Now, what does that mean in the context of parabolas and lines? This means that they are not going to intersect. I'm going to get something looking like this, where there are no points between here where these two graphs are going to cross. But that brings us to the end of the video today. Thank you so much for joining me, and I will see you next time.